PSRs. The point of safe return is the furthest point along track to which an aeroplane can safely fly and still return to the point of departure with the required fuel reserve. PSR is a measure of endurance. Here's the effect of wind on PSR for an endurance of 5 hours. Under 3 conditions: still air, 50 knot headwind and a 50 knot tailwind with a TAS of 300 knots. The formula is EOH over O plus H. In still air, substituting into the formula, E, which is endurance, is 5 hours, multiplied by the ground speed out and multiplied by the ground speed home, which in still air is 300 and 300. This is all divided by the ground speed out plus the ground speed home, which is 300 plus 300. Using a calculator, the distance to the PSR is 750 nautical miles. With a 50 knot headwind, the ground speed out is 250 knots and the ground speed home is 350 knots. Substituting into the equation, the distance to the PSR is 729 nautical miles. With a 50 knot tailwind, the ground speed out and the ground speed home values are reversed. Substituting into the equation gives a distance to the PSR of 720 nautical miles as well. The PSR is reduced by any wind. Here's an example. The distance from departure to destination is 360 nautical miles. Endurance is 4.5 hours. True track is 345. Wind velocity 26030. True airspeed 140 knots. What's the distance of the PSR from the departure point? Well, you need to use a CRP5. You'll need to use a CRP5 and put on the true track wind velocity and true airspeed to find out what the ground speed is. The ground speed out is 134 approximately, and the ground speed home is 139 approximately. With an endurance of 4.5 hours, these can be put into the equation to calculate a PSR of 307 nautical miles. Here's another example. The distance from departure to destination is 200 nautical miles. The endurance is 3 hours. TAS 130 knots. The ground speed out 150 knots. The ground speed home 110 knots. What's the distance to the PSR from the departure point? This time we don't need to use a CRP5 since the ground speeds are given, which makes the question a bit easier. The distance is actually irrelevant to the question. You need the value for endurance. Substituting into the equation EOH over O plus H, the PSR is 190 nautical miles. The distance from departure to destination is 240 nautical miles. Endurance 3.5 hours. TAS 125 knots. Ground speed out 110 knots. Ground speed home 140 knots. What's the distance and time of the PSR from the departure point? There's a little bit more to work out here, but the ground speeds are given. The formula is EOH over O plus H, and substituting those values in, you'll get a distance to the PSR of 216 nautical miles. Using the ground speed out of 110 knots, use that to calculate the time to the PSR, which is 118 minutes. Another example. Distance from the departure destination 215 nautical miles. Endurance 3.3 hours. True track 005. Wind velocity 29015. TAS 125 knots. What's the distance of the PSR from the departure point? We're using a CRP5. The ground speed out is approximately 120 knots and the ground speed home is approximately 128 knots. Substituting into the formula EOH over O plus H, the PSR is 204 nautical miles. And lastly, The distance from departure to destination is 300 nautical miles. The endurance is 4 hours. TAS 110 knots. Ground speed out 120 knots. Ground speed home 100 knots. What's the distance of the PSR from the departure point? Well, the distance to the destination of 300 nautical miles is irrelevant. So using EOH over O plus H, you'll get a PSR of 218 nautical miles.